Hi everyone, this is a reflection lecture for our reflection video for lecture 4 that took place on September 22nd, talking about chapter 5 here. It's our second lecture in chapter 5. We talked about different types of reactions. We finished up with our previous discussion, and then we delved into solubility a bit. Next stuff up is going to be more on redox chemistry and acid-base stuff. That will be on Wednesday. Alright, so I wanted to follow up a little bit on our exit tickets from last time. So this was again from our last lecture. There's a couple questions here, and one of them, the first two, were about identifying chemical reactions. And if you look at each one here, first one looks like people did pretty well on, but the second one was less people were not as strong on that, and the third one people struggled as well. So if we look through each of these, all right. So the first question is, which of the following is an example of an acid-base neutralization? A lot of you got this one correct, almost 90% of you. And again, for an acid-base neutralization, what we're looking for is something that's going to produce water, and the reactants are going to be an acid and a base. Now, you may not know all the acids and bases yet, the common ones, but we're going to learn those later, so this will be even easier to recognize. But the giveaway, the dead giveaway, is this here, this water. Okay, so something's producing water. There's only one of these that's producing water. But as you'll learn later, phosphoric acid here and potassium hydroxide, these are both, so this is strong acid, this is strong base. Their neutralization reaction creates this water and salt. So so it looks like you guys got that mostly right. This other one, it was a little more complicated. We're talking about an example of a redox reaction. What we're looking for is the change in the oxidation state. Now again, that term is not familiar with you. For right now, when we're thinking about metals, we're thinking about change of charge on that metal. And again, we'll get into more details on this on Wednesday. But if you look at this reaction here, right, so this one is an acid base, right? We know that's an acid base. If you look at the change on the charge here, right, the aluminum here has a charge of 0. And in the products, the aluminum has a charge of +3. So everybody can see that because there's 3 bromines attached to it, 3 bromides attached to it. So therefore, you went from aluminum 0 to aluminum +3. So that means we lost some electrons. And so at this point, that's all you really need to know. We're going to get to more details about what exactly the loss of electron is and why, how we characterize that and how we describe that in class on Wednesday. All right, and finally, last question is, which of the following is insoluble? Okay. And so it looks like about 50-50 you guys, 50% you got it right, and the majority of the people who got it incorrect picked silver nitrate. All right, I can see why people thought that, because silver is often not soluble with certain anions. But I made this little chart, which hopefully I'll share with you guys at class tomorrow. But the idea is you can sort of work through this. It's sort of flow chart if you're trying to figure out if something's soluble or insoluble. Let's say, is the cation group 1A element or ammonium? Or this when we're talking about the cation is silver and the anion is nitrate. And so no, this is not silver nitrate, or this is not the group 1A element or ammonium. So then you move on to the anion, and you say, is anion nitrate acetate or perchlorate? And if you say yes, which is the case here, it's soluble. Okay. So I'll run through a couple more examples, which were I put in our practice. So let's go back to our assessments and look at this one here. Alright, so we can follow the same logic here. Got a couple different ones here. So is the following soluble or insoluble? Right, we got ammonium phosphate. Right, so question 1 is the cation group 1A element or ammonium? Yes, it is, so you know it's soluble. Alright, so that one should be pretty quick to get to. And it looked like 100% of you got that right. So far we've tried it, now only a few. Alright, for the second one, I noticed the exit ticket has been having a snafu. Sometimes it doesn't show these subscripts very well, so I have been talking to the people at the tech support for exit ticket. Alright, so this one says, is the following compound soluble or insoluble? Calcium carbonate. And so what you do is you look back here, right? Is a group 1A element or ammonium? No. Is the anion nitrate, acetate, or perchlorate? No. Is the anion highlighted? No. Sulfate? No. Is it carbonate? Yes. That means it's insoluble. Alright, so this one is insoluble. Alright, so you can use this. I'm not going to give this to you guys on exams, but it's a good way to practice, right? And so you just need to remember, start with this cation, right? Because that's the shortest way to figure things out. Then if it's anion, ask yourself this question. And then if it's one of these other anions, right, what I would do is I would probably ask, the mental checklist, I would look for this. Is it a group 1A element or ammonium? Yes, then it's soluble. Is the anion nitrate, acetate, or perchlorate? Yes, then it's soluble. Is the anion carbonate? Yes, then it's insoluble. And then these two, you have to worry about the exceptions, right? If it is, then you have to wonder if it's, right, let's say it's a halide, and then is the cation associated with that silver, mercury, or lead? No, it's soluble. Yes, it's insoluble. But yes, I'll fix that. Okay. Alright, so with that, I will finish the reflection, and I'll see you all in class on Wednesday.